guys, welcome to my channel Mugambe Brand 256. So today we are going to look at an example involving the ray diagram construction, basically by accurate drawing. So in this example, an object of height 2 centimeters is placed at a distance of 3 centimeters from a concave mirror of focal length 6 centimeters. By scale drawing, determine the size of the image, its position and magnification. So basically we shall draw a Cartesian plane, and the horizontal axis will act as our principal axis. Then we shall have also the vertical axis, which is going to basically act as our pole of the mirror. So in this particular case, we have our object is of height 2 centimeters, and therefore first of all we shall put the scale. So for my scale here, I have 1 centimeter, which consists of 5 small boxes. 1 centimeter is going to represent 1 unit, or 1 centimeter on the graph is going to represent 1 centimeter. Okay, then along the vertical axis, the same thing. So I have 1 centimeter to represent 1 centimeter. Okay, so here I'll have 1, 2, 3, and 4. Well, I go back to the position of my object. My object is placed at 3 centimeters from the pole of a concave mirror. So this is my concave mirror. So this is indicating the concave mirror. So here we have the pole of the mirror. So my object is positioned 3 centimeters from a concave mirror, and then it is also of height 2 centimeters. So that is my object there. So we have to recall the guidelines for ray diagram constructions, and for this particular case, since our focal length is 6 centimeters, definitely our center of curvature is going to be twice the focal point, which is going to be 6 times 12, 6 times 2 giving us 12. Then going back to our guidelines, we say that a ray of light that is close and parallel to this principal axis here is going to be reflected through the focal point. However, this ray here is going to appear as if it is coming from this other side here in a straight line. Then the other guideline is a ray of light that is going through the center of curvature is going to be reflected back in the same path. But as it is coming back after striking the reflecting surface of this mirror here, it is going to appear as if it is coming from behind the mirror. So where we have the point of intersection of these rays, that is where we are going to form our image, and therefore we shall position it at that point there. So we shall be interested in finding this distance behind the mirror, this distance here. Well, so that is where our image is going to be. So first of all, this image that has been formed is behind the mirror, so it implies that this image is going to be virtual. So if you are to compare the sizes, look at the size of the object and the size of the image, you realize that the size of the image is bigger than the size of the object, and therefore in this particular case we are having a virtual and magnified image. Anyway, let's go back to the question. We are required to determine the size of the image. When they talk about the size of the image, we basically mean the height of this image here that has been formed. Well, we go back to our Cartesian plane here that we use to find out. So here we count off 1, 2, and then 3 centimeters. So realize that it is coinciding with the 4 centimeter mark up here. Therefore, the size of the image is 4 centimeters. So we go to the position. Well, when we talk about the image position, we basically want the distance from the distance between the mirror and the image that has been formed. And this distance here from here up to here is 1, 2, 3, 4, here is 5, and then here is at 6 centimeters. 6 centimeters behind the mirror. So the image position is 6 centimeters, or you can also call it the image distance. So if you're also asked about the image distance or the image position, so give us here, it is 60 centimeters. Then finally, we are required to find the magnification. So the magnification is given by the image distance divided by the object distance. The image distance from the mirror is going to be 6. So it is the 6 that is here. And then the object distance, the distance between the object and the pole of the mirror is 3 centimeters. So now we're having the distances in centimeters, and therefore our magnification is basically, it does no units. Reason being, it's a ratio of two similar quantities, and in this particular case here, the magnification is 2. So that means the image here, its size is twice that of the object. Thank you viewers for watching. We'll meet next time.